Okay, we did pretty well there. We saw that pretty quickly. Look at this triangle. Well, this distance is A. A alpha. I should have used a different Greek letter. But this distance is A. Okay? Mm-hmm. And then I said, well, what else do you know? And somebody said, well, this angle up here is alpha. Okay? And that's true, assuming that these are parallel. Well, then they've got to be parallel to this one, right? So if I draw a perpendicular to this side, through this point, we can see clearly that this angle is alpha. I mean, that's how we defined it, right? And then this side being perpendicular to this side is going to be perpendicular to this, okay? And this angle's got to be alpha. And you can work out the details of that. That's ninth grade geometry. But in a context that would throw most ninth graders, unless you phrased it very carefully, right? So here your angle is alpha. Okay. Well, then you can calculate the other sides, right? Okay? And you can do that. I'm not going to do it for you. But the other thing we have to observe then is, if these are parallel, well, that means both this angle and this angle are right angles, right? So that this is an isosceles triangle. Now, it's not really a triangle if these are right angles. So they're very slightly less than right angles, okay? But you still have equal distances. It's like two railroad tracks, okay? Even if they eventually meet at a long distance, okay? Well, I'm not going to go on with that analogy, but it should be clear that if these are right angles, or if these angles are equal, you know, if one's a little less than a right angle on this side, one's a little less on this side, where this really is the angle, it's clear. You have similar triangles here and here with the green line and the purple line, right? So for all kinds of reasons, this distance is the same, so what's the difference in the distances?
Bottom leg there.
Yeah, this leg, right? Okay, so we conclude there's your difference in the distances, and what is that difference?
A alpha sine. Sine alpha.
Yeah, you're thinking reverse Polish notation. Yeah, A sine alpha. Said A alpha sine.
Yeah.
Okay? A sine alpha. Right? That's a whole lot easier than simplifying the Pythagorean theorem expressions for those two distances. But if you simplify it with this assumption, you end up with the same conclusion. But it's much easier to see here. You can't really see it with the Pythagorean theorem, you know, by applying the Pythagorean theorem to the two distances. Although you can see that when you do the right thing in simplifying it, it comes out this way. That's worth seeing. We probably don't have time right now. Okay? And we'll do something much more complicated in differential equations. So you'll have had the experience one way or the other. Very good.